Hello, welcome to our channel Elimika Mtandaoni. My name is Agustino Mogosi. Today we are proceeding with a series of lectures on Introduction to Information Systems, and the focus of today's lecture is on Foundations of Business Intelligence. And here particularly we'll be talking about the databases and information management. So before we start discussing about databases, let me take you back to what we called traditional file system. Traditional file systems. Before the invention of databases, the records or data were stored in what we call files, and storing of data in files resulted into several problems. Among the problems that were caused by a traditional file system, one was data redundancy and inconsistency. Speaking of the word data redundancy, it means that it was possible for data to be duplicated in different locations. As we know that we have different departments. So with the file systems, what is done is each and every department has its own files, and in that case it is very possible for one particular data to be stored in different locations if it happens that these data belong to several other departments. So the problem of data redundancy and inconsistency is being brought because data could not be centralized. And speaking of inconsistency, it means that data, you could have the same data but different values. So you will find probably speaking of a same person but can be recorded several times using misspelled names or different values but in the end, if you look closely, you will find that these are the same belong to the same person. So it creates what we call inconsistencies. So traditional file system has one biggest problem, and this is data redundancy and inconsistency. There is another big problem that was brought by file system. This is what we call a program data dependence. Data dependence. We say it's a program data dependence. Program data dependence. This means that if you were to effect changes to a data, then you had to make changes to your program, because program and data are coupled together. So if they are coupled together, that means any change that you want to do to your data, then you need to make changes to the program that exists. So this is also taken as another problem in traditional file system. The third problem could be poor security, because with the file systems there are no mechanisms that could protect data from being affected or from being insecure. So poor security is another problem that may rise. The fourth problem could be lack of flexibility, as we have seen that to make changes to this data becomes a daunting task. So these are the problems with the traditional file systems. So what's the solution? The information system solution is to introduce what we call a database. Speaking of the word database actually is a collection of related files that contain records of people, places, or things. So if we want to store information about people, or we want to store information about things or places, then these informations can be stored in a large collection of files that we call it a database. That means if you are talking about keeping records in a file system, the records is stored in a hierarchy that starts with the bits, and the collection of bits make what we call bytes, and collection of bytes, they create characters. So, and if we have these characters, then they make fields. Then from fields you get what we call records or tables, and and there you get the database. So if you are recording files, you are recording data in a database, then the simplest unit of data recording starts with a bit, and a bit, collection of bit creates a byte makes a character, etc., etc., until you come to have a large collection of these files that we call database. So in a database, there are some records of people, records of places, records of things. It depends on what you are recording about. For example, if we want to have records about students, then there is a possibility that we can have records about the students themselves. We can have records about the courses that they take. We can have records about the instructors that teach these students. So if we go back and say what a database is, in those days we had databases, but they were not computerized. So in modern ways now we have computerized the databases that they make information system to be effective. They make information system to be effective, and as we know, for an information system to be called effective, then it should be timely, it should have information, or it should provide users with information in a timely manner. It should provide relevant information, and it should provide accurate information. So an information system to be effective, then it provides users with relevant information. When you say relevant information, it means it's a kind of information that is useful or it is appropriate to the decision makers. And information system which is accurate, information which is accurate, it means that it is free of errors, and it should be available when needed. That means it should be timely. So an effective information system is the one that provide the users or provide the decision makers with information that has these features, that is timely, relevant, and accurate. So our computerized databases have come to enhance these information systems, to make databases which are more effective. They are more effective. So now let us talk about different types of databases. As you know that we have different database models. Speaking of database models, it is like we are talking about different types of databases. There are some types of databases that we call network databases. We have some databases that we call object-oriented databases. We have some databases that we call cloud databases, and so many other databases. We have another models of databases that we call relational databases. These are the modern types of databases, or the modern models of databases. But the most popular model of database is the one that we call relational database. This is the most common type of database. In this type of databases, data is represented in rows and columns in a two-dimensional table. That means data are represented in a kind of table like this, where you have rows and columns. As you can see, these ones here are the ones that we call columns, and these ones here are the ones that we call rows. So representing your data in a two-dimension form, where data are stored in rows and columns, that is what we call a relational database. So any database contains data on an entity and its attribute. That means when you're talking about relational databases, that means you are talking about entities. Speaking of the word entity, it's just a representation of the place, representation of things, representation of let's say people, etc. And as we know that entities have characteristics, we call them attributes. For example, think of an entity called a student. Then a student could have a number of characteristics that we call attribute, that include student number, or student name, or student date of birth. So those are the ones that we call attributes. We'll talk about attributes and entities in the coming slides. Now let us talk about these entities and the attributes. Here we say an entity is an object that exists. It means that it's a representation of a place, is a representation of people or a person, or a representation of an object or any single thing. But this representation is of the things that we want to store records about them. For example, if we want to store records about computer parts, then we can have an entity called the computer parts. If we want to store information about students, then we can have an entity that is called a student. If we want to store information about instructors, then we could have an entity called the instructor. So they are like objects, they are like places or things that whose records we want to store. So we call them entities. But these entities have what we call attributes. Speaking of attributes, these are information about those entities. They are like descriptions of the entities. They talk about the entity. For example, if you are talking about the entity employee, that means employee can have some characteristics such as the ID of that employee, the enrollment, the location of that employee, the name of that employee, the address, the phone numbers, etc. So those descriptions or characteristics of the entity are the ones that we call attributes. Now let's talk more about these entities and the attributes. So the entities are the ones that we can convert into tables. So if we have an entity, let's say an entity called the supplier, then that entity called the supplier can have some attributes like supplier name, supplier number, supplier name, supplier street, supplier city, supplier state, and zip code. So these ones here are the ones that we call the attributes because they talk about the entity called the supplier. Okay. Now after you have understood about these entities, etc., then we can again talk about keys. But before that, let's come back here and look at this table here. Let us look at this table here. As you can see, this table here, it has a supplier number, and at the column supplier number, or the attribute or the field called the supplier number, there is a key field. A key field is actually an attribute that uniquely identifies that particular entity, and if it is designated, if it is selected among several other keys, then we call that a primary key. So the rows that we call them the records, or technically we call them tuples. These rows, if they are put in a table, then the row that contains a primary key or a key field should be a unique one. So speaking of a key field, is a field in a table that uniquely identifies each and every record in that row. That means if you select that a column to be called a key, then there is no way data in those in that column would duplicate. It means that in a relational database we have one or more columns that we can select them to be called the keys, and if it is called a key, that means it can uniquely identify a particular record in a table. So if we select one or two among these keys, the one that is designated, then we call that kind of key a primary key. So if we have two tables that relate, let's say we have table student and table course. We say student takes a certain course. Then the one among the primary key can move to another table. If it happens that a primary key of one table is found in another table, then that other key in that other table will be called a foreign key. So when a primary key appears in another table, then we call it a foreign key. And we can see that when we talk about relationships. Now let us talk about a kind of diagram that we call entity relationship diagram. This is a schema that is used to clarify table relationship in a relational database. That means you can have two or more entities that relate to one another. As I told you, we can have, let's say, an entity called the student, and another entity called the course. And then you can have a relationship that says student takes a course. So this kind of diagram, we call it the entity relationship diagram. And in some books, you will find that a relationship is represented by a kind of a diamond. It's like this. So this here is an entity. We call it an entity. Is represented by a square. Then, and this one also is an entity. Is also represented by a square. But a relationship is represented using a diamond. So if you want to display the attributes in one entity, then you could use an oval shape. So you could say student has a name, student has an ID, student has a date of birth, etc. So these ones here, we call them attributes. So if you are talking about entity relationship diagram, then it is made up of four important things, in fact. We have the attributes, the entity, and the relationship. So that is what it means by relationship. Now, if we want to establish a relationship, let's say we are establishing a relationship between two entities. Suppose we say that we have supplier supplies a part. We have this kind of relationship. A supplier supplies a part. Then there is a kind of relationship here which we call supplies. Okay, so then you can ask yourself whether there is a possibility of one supplier to supply more than one parts. Then you will find that the relationship between supplier and parts is that a supplier can supply more than one parts. We use this symbol like a crowfeet to represent there is a many relationship. But speaking of a part to be supplied by more than one suppliers, no, that is not possible. So we say this is one. So this kind of relationship which one supplier can supply many parts, this kind of relationship we call it a one-to-many relationship. And we have so many other types of relationship. We have one-to-one relationship, one-to-many relationships, and we have many-to-many relationships. So if we are establishing a relationship between these entities, then we must ensure that some integrities are followed. There are different integrities that are there when we are establishing relationships in databases. The first integrity is what we call referential integrity. Referential integrity is a kind of relationship between two tables that are coupled and they remain consistent in that way. So if when there is one table has a foreign key that points to another table, then you cannot add records of that other table if that record does not exist in this first table. So if you create a relationship between a supplier and parts, and you find that these two tables have a relationship, it means that the primary key of supplier, let's say it is an ID, will also be found in the part here. You will find an ID. Apart from the primary key for the part, that can be, let's say, part ID. So you will take also another primary key of the supplier, that is the ID. That means if you have a primary key of supplier in this other table that we call it part, then this key here, ID, that belongs to supplier, this one here will be called a foreign key. So when we talk about the referential integrity, it means that if you come to a point that you want to add a table, you want to add data in these two tables, that means the supplier table and the parts table, then it is impossible for you to add a data in the supplier table in the column of ID if it does not exist in the supplier table. Okay, so that is how referential integrity works. But also we have other integrity types like integrity types like entity integrity. When we talk about entity integrity, it means that any entity has a primary key, and if an entity has a primary key, then you cannot put a null value in the field of a primary key. So if there is a field that is marked to be a primary key, then it can never be null, nor can it be or contain duplicate data. Now, after we have seen how we can design a database, then let us talk about the database management system or database management software. Speaking of a database management system, is actually a software that is used to create, to store, to organize, and to access data from a database. So if you want to create a database, you use this software that is called the database management system. Or if you want to store data in a database, then you must use this software that is called the database management system. There are different types of databases. There are different types of databases or database management systems. There are those that are for desktop computers. For example, you have Microsoft Access. You may come across this type of software that is called the Microsoft Access. Microsoft Access is one among the types of database management systems, but this one works only with the desktop computers. And you can have many other types like DB2, the Oracle database, the Microsoft SQL Server. All these are database management systems that we can find in some local computers like desktop computers, but in most of the time they act as database servers for large mainframe computers or mid-range computers. But there is the most popular open source database management software, which we call MySQL, and there is another one that we call Oracle. This belongs to Oracle company, etc. It is proprietary software. So if you are looking for a free type of database management system for you to use, then there is this an open source database management system that is called MySQL. All these products of relational database, they support relational database. Now let's proceed with capabilities that a database management system can provide. When we talk about database management system, it has several capabilities and it has a lot of tools. These tools are for organizing, for managing, and for accessing data in a database. So these tools, sorry about that, these tools or the capabilities, they include data dictionary, data definition, and data manipulation language. So speaking of data dictionary as a capability, it is used to specify the structures of the content of the database. So if you want to create a structure of a database, for example, if you want to create a table, then you need data definition language. If you want to create, let's say, a view, or you create even the database itself, or providing the structure of a database, you must have the capability that is provided by database management system. That capability, we call it data definition language. But there is also data dictionary. This is actually either a manual or automated file, but it stores definitions of data elements and their characteristics. For example, if you have defined a certain data element, let's say an attribute, then a data dictionary will be the one to define several characteristics about this dictionary, about this attribute. Now, for querying and reporting, we need a capability or a tool for accessing or for manipulating such information in a database. Most database management systems have a specialized language that is called the data manipulation language. This type of language is used to add, to change, to delete, and even to retrieve data in the database. So if you want to, let's say, add some data in your database, or you want to change some data, so let's say you want to modify, to update your information in the database, then you need this type of language that is called the data manipulation language. In fact, this type of language contains commands, a lot of commands that they can allow user or a programmer, any specialist to extract data from such databases. So the most prominent or the most used data manipulation language in today's world is what we call structured query language. It is pronounced as SQL, or you can just say SQL. So for querying and reporting information from a database, then you need a data manipulation language. And the most prominent data manipulation language in the world today is what we call SQL or SQL language. It is written in this way. It is written in this way. For example, if you want to extract data, let's say, data from two tables, let's say table parts and table supplier, then you can write a kind of command like this. You say, for example, you have let's say a table called student. Suppose you have a table called student, and this table student has attributes like ID, attributes like name. So you want to get information from student, and the information include ID and a name. So what you can do is you can write a command like select. You say select. Let's write this properly. So you write the word select, and then it is followed by the attributes that you want to extract. For example, select ID, you put a comma. If you want to select another attribute, let's say name, you say select ID and name, but you can use a keyword from to indicate where you want to select this data from. So you say select ID name from, then you put the table name here. For example, the table is student. The table is a student. So select ID and name from student. So this type of language is what we call SQL language, or a structured query language. If you take a database course, then you will get to understand more about these languages. As for now, let us proceed with another type of database system that we call object-oriented database management system. As I told you that we have several other models of database apart from relational databases, and this is what we call object-oriented databases. Object-oriented databases, they store data and procedures. Not only data, they store data and procedures. And these data and procedures, they actually act as objects, and they can automatically be retrieved and shared to other databases. So we have this, what we call object-oriented databases. It's a current technology, and most of the systems nowadays use these object-oriented databases. This includes, because it supports even multimedia forms of storage. For example, YouTube videos, they can be stored in this kind of database that you call object-oriented databases. Now, how can we use databases to improve business performance? Businesses actually use databases in order to keep track of basic transactions. So there are several transactions that occur in businesses. So if you want to keep track of these transactions, then you need to store information about these transactions. You need to know if there are some changes that have been made in certain transactions. In order to facilitate that, if, for example, you are paying a supplier, or you are receiving a payment from a customer, or let's say you are processing an order, or you are serving certain customers, or you make certain payments, then all these information, they need to be recorded. They need to be stored. And the part where you can store this information is what we call databases, and with the help of database management systems. But also, businesses, they need databases to provide information that will help them run their businesses more efficiently, and in that case, they will help managers and employees to make better decisions, because we know information is power. So if you have records, then you can use such records to make several several decisions that can help to make your a company perform better. Now let us talk a more advanced type of databases. We call it a data warehouse. A data warehouse is a kind of database that stores current and historical data of potential interest to decision makers throughout the company. The point here is, when you are talking about data warehouses, it's not like other databases. Other databases, they store information in a kind of real time. That means if you make some changes, the time you make the changes, then the changes are affected in the particular databases. But speaking of data warehouses, they store some historical data, for example, and they normally deal with subject oriented. For example, they store data about sales, they store data about customers, or they store data about suppliers. Speaking about a particular subject, one particular subject, after transactions have been done, then that particular subject information is the one that is taken and is stored as historical data. If that kind of recording is done, then that type of database, we call it a data warehouse. Actually, these data that are stored in data warehouse, they originate from operational transactions. For example, the sales systems, or the customer accounts, the manufacturing and production systems, or web transactions. So these TPSs, the MIS and DISs, etc., their data can be taken and be stored as historical data in other databases that we call a data warehouse. A subset of a data warehouse is the one that summarizes or highly focuses on a certain portion of organization data. For example, a certain portion of data in a certain department. That kind of database, we call a data warehouse, we call it a data mart. A data mart is taken as a subset of data warehouse. So speaking of a data warehouse, it has several components. That components that include the transaction data, then the data from these transaction systems, they are extracted, they are transformed and loaded into this data warehouse. So data from these transaction systems or external data sources are then taken into this part of the data warehouse, where they are extracted, they are transformed and loaded. So they are loaded into this data warehouse, and from this data warehouse, there is where we can do different analytical activities like data analysis, querying and reporting, online analytical processing, or data mining. So all these other activities that are done, they are done from a larger part of a database that we call data warehouse. Now let us talk about business intelligence, because we have seen the foundation of business intelligence lies on the understanding of databases. So after you have a databases, then the data that are stored in normal databases then are taken as historical data and is stored in a larger database, which is a centralized database where we can perform analytical operations. That kind of database, we call it a data warehouse. So once data have been captured and organized in these data warehouses, then they are available for a further analysis. So there is a series of tools, a set of techniques that can be used to analyze data. And in these techniques, they see some patterns, they see some relationships that exist between data or the insights. And these insights, the patterns or the relationship, they are the ones that are very useful for guiding in the decision-making process. So the tools for consolidating, for analyzing, and providing access to a large amount of data so that such data can help users to make better decisions. So those combination of those tools, we call them business intelligence. So in fact, a business intelligence is just a combination of tools and techniques for consolidating, analyzing, and providing access to large amount of data so that this data can help the decision makers to make better decisions. So the principal tools for business intelligence, they include software like database querying tools. We have software like database querying and reporting tools for multi-dimensional data. We have some analytical processing tools. We have some data mining tools, etc., etc. So we have several tools that we can use for data mining. As you can see here, we have databases. These databases, they keep track of the transactions. And after we have captured data into these normal databases, then data are taken into a more advanced type of databases that can store current and historical data. Such advanced database is the one that we call a data warehouse. So data from normal databases are then taken into data warehouses where we can find the patterns and insights of data through several techniques like OLAP. When we say OLAP, that means online analytical processing, or we can do what we call data mining or querying and reporting. And doing this is what we call business intelligence, and it will help the decision makers to respond to the patterns, the insights, the relationship that exists between these data. And in that case, this kind of analytical processing, or this kind of data mining, or this kind of querying and reporting will be the ones that will help decision makers to make their decisions, and in that case will help to improve their performance of their organizations. Now let us discuss about online analytical processing. We call it OLAP. This is among the tools. That means when we talk about business intelligence tools, then online analytical processing is one among the tools. It supports multidimensional data analysis. That means you can look at data in different multiple dimensions. For example, think of this. You can look at a product in several aspects. For example, you can look at a certain product basing on its price, basing on its the region where it is processed, basing on the period where it is a time period where it is should be used. That means the expiry date, etc. So a product manager could use multidimensional data analysis tool in order to learn how many, let's say, people or how many products can be sold in East Africa, let's say in January, or how many computers have been sold in Dodoma at a certain date. You see several dimensions. You see a product is computer, so you see how many computers can be have been sold this January at the region called Dodoma. You see, so OLAP enables users to obtain some questions, to some answers to certain questions, and questions can be even ad hoc questions. Such questions include, let's say, when the data should be stored. Let's say, when should we produce a certain product? At what cost should we sell this product? Those are business questions that can be answered using online analytical processing. As you can see this dimension here, you can see this multiple dimension of a product. You can see it has several dimensions. The first one is the product, then the second one is the region, then the period. The product, we have the nuts, the bolts, the washers, the screws. If you want to know how many washers have been sold in East Africa, the actual and the projected, then we go to this dimension here. Or if we want to know about bolts, how many bolts have been sold in West Africa at a certain actual period, so we go to this dimension here, come to bolts and a certain actual period, which is here. So we take this block 1 here as our dimension. Most of these multidimensional databases, we will discuss this when we talk about decision support systems. For now, this is just a foundation of business intelligence. We're just giving you some tips, some hints of what comprises of business intelligence. Now let us talk about data mining. This is also another tool or another technique that makes what we call business intelligence. Data mining is actually is a kind of activity that does a discovery of patterns. It provides some insights where you can corporate data that cannot be obtained from all-up techniques. And in that case, you will find some hidden patterns. You will find some relationship that exists in these large databases. And in that case, you will infer some rules from them, and you can make some prediction of the future behaviors. So you learn from patterns and the rules that are used to guide decision making, and you can forecast the effect of those decisions. There are several techniques under decision support systems. There are several techniques. Such techniques, they include associations, classifications, clustering, forecasting, and predictive analysis. So starting with the associations, what is association? Association is a kind of technique where occurrences are linked to a single event. Occurrences are linked to a single event. If you ever visited a supermarket, you will find that if you went to a place where you want to take, let's say, tea or coffee, then you will find some other stuffs that relate somehow with the tea or coffee. For example, in the same shelves, you will find about sugars. You will find about stuffs, about other stuffs like cocoa, etc. that they relate to a certain event, that is a drinking event. So you want to have some hot drink. Then hot drink, it can be tea, it can be sugar, and they need some other stuffs like sugar, milk, coffee, etc. So association technique is the one that occurrences are linked to these single events. We have another data mining technique that is called declassification. This kind of technique recognizes patterns that describe the group to which an item belongs. So you can classify items depending on their groups, and you can do this by inferring to a set of rules. So you classify objects based on the inferred rules. But another type of grouping is what we call clustering. A data mining tool that you can use that is called clustering is used to discover groupings within the data, such as if you want to find some affinity group for, let's say, bank cards, or you want to partition database into groups of customers based on demographics and types of personal investments. So clustering differs somehow from classification in the fact that with the classification there is a kind of supervision, but clustering there is no kind of supervision. How about forecasting? Forecasting is you do prediction in different ways. So you use a series of existing values to forecast what other values would be. For example, you go back 3 or 4 years and you see what your organization has performed, how your organization has performed. Then you use those data from the previous years to predict the coming year, and that is what we call forecasting. It differs from predictive analysis, where predictive analysis actually uses other techniques like data mining techniques, or it uses historical data, or it uses several other data to produce or to make assumptions or to predict about whatever future outcomes or future events will be, such as, let's say, what if you raise the price of your product? Then if you want to know that, then you can use a technique like this, what we call predictive analysis techniques. Many companies nowadays use web-based systems. So if they are used web-based systems, then some of these information that they have, they are stored in their internal databases, and some will be stored in over the internet. So prospective customers can access the website of these companies, and in that case they can view data from the database of these systems. So databases help, web systems help easy access of databases over the internet. Ending up our topic today, let's discuss about managing data resources. There is one thing that we call information policy. Information policy, what it does, it specifies the organization's rules for sharing, for disseminating, for acquiring, standardizing, classifying, and even inventorying the information. So there should be some rules, some guidelines that make sure that a certain organization follow so that data can be stored. There must be a kind of policy that should be followed. It's not easy that you just store data anyhow that you want. You need a kind of guidance, and that is what we call information policy. Speaking of data administration, actually this is responsible for specific policies. So if you have set a policy or you have set a procedure, then you want to manage those data to make sure that there is good organization of such data. You need administration. So data administration means is the responsibility of making sure that the policies or the rules or the procedures are followed within an organization. So thank you very much for following Elimika Mtandaoni. Today we had a useful lecture on a foundation of business intelligence. Remember, as we are saying that this is a foundation, it means that it's just an introduction. It prepares you to a better course that is called a business intelligence. So you can take your time and dig more on databases, dig more on data warehouses, dig more on data mining tools, the techniques that are found under data mining tools, etc. And make sure that the data that you collect, they are collected in the high quality. So you have to design your databases following the information policy so that you can have data which are accurate, data which are consistent, and data which are very useful. Thank you.